Hello and greetings to everyone. We are going to continue from where we ended last time with the corrections of the following exercises for application. We are to solve the following quadratic equations by making use of any of the methods we learned last time to solve quadratic equations. So we are going to make use of any method of our choice. Take solution. For question A, we have to solve the quadratic equation 2y squared plus y minus 1 equal to 0. Solving this quadratic equation, we are going to make use of the method of factorization. First thing, we need to start by finding two numbers such that their sum is equal to the coefficient of y here, which is 1, and their product is equal to a times c 2 times negative 1, which is equal to negative 2. You will see that those two numbers must be 2 and negative 1. 2 plus negative 1 is the same as 2 minus 1. It gives us 1. 2 times negative 1 gives us negative 2. This will give us 2y squared plus 2 plus negative 1 times y minus 1 is equal to 0. This will give us 2y squared plus 2. We know when we have positive, negative is equal to negative. So negative will be here, 2 minus 1. All this times y minus 1 is equal to 0. The next step, we are going to expand this bracket. This will give us 2y squared plus 2 times y gives us 2y. Negative 1 times y gives us negative y minus 1 is equal to 0. Next, we are going to factorize this pair. Then we factorize this other pair. Looking at the first pair, 2y is common. We are going to factor out 2y. 2y times y gives us 2y squared plus 2y times 1 gives us 2y. At this second pair, you'll see that negative 1 is common. We are going to factor out negative 1. Brackets open. Most of them, when we factor out negative 1, we are just going to put the negative sign. When you see nothing here, just know there is 1 present here. Times, we know negative 1 times y will give us negative y. Negative 1 times positive 1 will give us negative 1. This will equal to 0. Now we have two terms. Looking at the two terms, you will notice that y plus 1 is common. We are going to factor y plus 1 out. Y plus 1 times 2y will give us 2y times y plus 1. Y plus 1 times negative 1 will give us negative y plus 1. We are going to equate it to 0. At this level, we are going to say either y plus 1 is equal to 0. If this product is equal to 0, either the first one is equal to 0 or 2y minus 1 is equal to 0. We have two linear equations. We are going to solve for y in the two equations. In the first one, y will simply be equal to, we are going to transfer 1 to the right hand side. It becomes negative 1. For the second linear equation, this will give us 2y to be equal to, we transfer negative 1 to the right, it becomes positive 1. Now for us to get the value of y, we are going to divide all through by the coefficient of y, which is 2. We divide here by 2. This will give us y to be equal to a half. So these are the values of y. Y is equal to negative 1 or y is equal to a half. Now we move to Question B. For question B, we have 2 plus 2x minus 2x squared is equal to 0. First thing, we are going to arrange this our quadratic equation. This will give us negative 2x squared plus 2x plus 2 is equal to 0. Next thing, we need to eliminate the negative sign in front of the coefficient of x squared. We are going to multiply both sides by negative 1. This will give us negative 1 times 2x squared plus 2x plus 2 is equal to negative 1 times 0. This will give us negative 1 times negative 2x squared will give us 2x squared. Negative 1 times positive 2x will give us negative 2x. Negative 1 times positive 2 gives us negative 2. And this will be equal to negative 1 times 0 gives us 0. Next step, at this level, you will see that we can factor out 2 at the left hand side. If we factor out 2, we'll be left with 2. This will give us 2 times x squared minus x minus 1 is equal to 0. Next, we are going to divide both sides by 2. We divide here by 2. Then we divide 0 by 2. 2 and this 2 cancel. This will give us x squared minus x minus 1 is equal to 0 divided by 2 is equal to 0. Now we can solve this our quadratic equation. We are going to solve this one by method of completing the squares. First step, our coefficient of x squared is already 1. So we are going to send the constant term to the right hand side. This will give us x squared minus x is equal to 1. Next step, we are going to add half the coefficient of x, all that squared, at the left hand side and at the right hand side. This will give us x squared minus x plus, here the coefficient of x is negative 1. The half of negative 1 gives us negative a half. And we square it. This will be equal to 1 plus negative a half squared. This is a perfect square, and the factorization is simply x minus a half, all this squared, is equal to 1 plus negative 1 squared gives us 1 all over 2 squared gives us 4. Now at this level, we need to simplify the right hand side. We know 1 can be written as 1 over 1. This will give us x minus a half squared is equal to, we know the LCM of 1 and 4 is 4. 4 divided by 1 gives 4. 4 times 1, 4, plus 4 divided by 4 gives us 1. 1 times 1, 1. This will give us x minus a half squared is equal to 4 plus 1, 5 all over 4. Next step, we are going to take square root at the left hand side and at the right hand side. This will give us the square root of x minus a half squared is equal to the square root of the fraction 5 all over 4. This will simply give us x minus a half is equal to plus or minus the square root of 5 on 4, which is x minus a half is equal to plus or minus the square root of 5. We know the number 5 is not a square number, over the square root of 4. We know the square root of 4 is 2. Next step, we are going to send negative a half to the right hand side. This will give us x will equal to a half plus or minus the square root of 5 all over 2. This will simply be equal to, the denominators are the same, 1 plus or minus the square root of 5 all over 2. At this level, we are going to obtain x to be equal to 1 plus root 5, because you cannot be working with addition and subtraction at the same time. 1 plus root 5 divided by 2, or x is equal to 1 minus root 5 divided by 2. So these are the solutions of given quadratic equation. We go now to question C. For C, we have been given the question 18p squared plus 8p minus 3 is equal to 0. We are going to answer this question by making use of the formula method. We are going to compare this our quadratic equation with the general form of the quadratic equation. We are going to compare it with a p squared plus b p minus c is equal to 0. We are comparing these two equations, this and this. This is p squared. Our a will simply be 18. pp, our b is equal to 8. 0, 0. This is plus. Our c will simply be equal to negative 3. Now, by using our quadratic formula, we are looking for p. P will simply be equal to negative b plus or minus square root of b squared minus 4ac. Then we divide all this by 2a. It will simply be equal to, we know b is 8, negative 8 plus or minus the square root of 8 squared minus 4 times a. Our a is 18 times c. Our c is negative 3. Then we divide all this by 2 times a, which is 18. This will give us negative 8 plus or minus the square root of 8 squared gives us 64. Next, if we take negative 4 times 18 times negative 3, the answer will simply be positive 216 all over 2 times 18 gives us 36. This will simply be equal to negative 8 plus or minus the square root of 64 plus 216 gives us 280 over 36. Next step, the number 280 is not a square number. So if we take the square root of 280, we are not going to obtain a whole number. Most often it is good if we leave the result in set form. We know 280, if we take 280, it is equal to expressing as a product of two numbers in which one of the numbers is a square number. We can write it as 280 equal to 4 times 70. If we take square root on both sides, the square root of 280 will be equal to the square root of 4 times 70, which is equal to the square root of 4 times the square root of 70. This will simply be equal to, we know the square root of 4 is 2 times root 70. So this will give us 2 root 70. Take note of this. We are going to see this under sets. This will be equal to negative 8 plus or minus. I'll replace the square root of 280 with 2 root 70 all over 36. At the numerator here, I will factor out 2. I know 2 times negative 4 will give negative 8. Then I'll put the plus or minus. I know 2 times root 70 will give 2 root 70 all over 36. This will simply be equal to 2 will go here 1, 2 will go into 36, 18 times. This will give us negative 4 plus or minus root 70 on 18. At this level now, we are going to say P is equal to, because we cannot be working with addition and subtraction at the same time, P will be equal to negative 4 plus root 70, all this divided by 18, or P is equal to negative 4 minus root 70, all this divided by 18. We are going to leave our answer in this form. Now we move to question D. For question D, we have 12 cure minus 9 cure squared is equal to negative 3. We are going to arrange this our equation, and we are going to transfer negative 3 to the left hand side. This will give us negative 9 cure squared plus 12 cure plus 3 is equal to 0. Next, we are going to multiply out by negative 1. Negative 1 times 9 cure squared plus 12 cure plus 3 is equal to negative 1 times 0. Negative 1 times negative 9 cure squared will give us 9 cure squared. Negative 1 times 12 cure will give us negative 12 cure. Negative 1 times 3 will give us negative 3 is equal to negative 1 times 0. We use 0. Here, we are going to factor out 3, because 3 is the highest common factor of 9, 12, and 3. Forget about the negative signs. We are going to factor out 3. 3 times 3 gives 9. We attach cure squared. Minus 3 times 4 gives us 12. We attach cure. Minus 3 times 1 gives us 3. This will be equal to 0. Next, then we are going to divide both sides by 3. 3 will cancel 3 here. We'll be left with 3 cure squared minus 4 cure minus 1 equal to 0 divided by 3 gives 0. At this level, we are going to make use of the quadratic formula. Comparing this quadratic equation with the general form of the quadratic equation, let's assume this is our general form: a cure squared plus b cure plus c is equal to 0. If we compare these two equations, cure squared, a will be equal to 3, b will be equal to cure, b will be equal to negative 4, and c will be equal to negative 1. By using our quadratic formula, using cure equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a, this will simply be equal to negative 4 plus or minus the square root of negative 4 squared minus 4 times a. Our a is 3 times c is negative 1, and we divide by 2 times a, 2 times 3. This will simply be equal to negative gives us positive. 4 plus or minus the square root of negative 4 squared gives us 16. Negative 4 times 3 gives us negative 12. Negative 12 times negative 1 gives us positive 12. 16 plus 12 divided by 2 times 3 gives us 6. This will simply be equal to 4 plus or minus the square root of, we know 16 plus 12 gives us 28 all over 6. You'll see 28 here is not a square number. For us to get the square root of 28, we know 28 can be written as 4 times 7. We take square root on both sides. This will simply give us the square root of 4 times the square root of 7, which is simply equal to 2 root 7. We are going to replace root 28 here with 2 root 7. So this will be equal to 4 plus or minus 2 root 7 all over 6. At the numerator, we can factor out 2. We know 2 times 2 is 4. We put the plus or minus. 2 times root 7 gives us 2 root 7. We divide by 6. This will be equal to 2 plus or minus root 7 all over 2 where 1, 2 go into 6 3 times. At this level, we can conclude Q will be equal to 2 plus root 7 on 3, or Q is equal to 2 minus root 7 on 3. So these are the two values. We move now to question E. For question E, we have x plus 7 all over x plus 1 is equal to 2x plus 8 all over x plus 1. For us to solve this question for the unknown x, first thing, we are going to start by cross multiplying. We are going to take the numerator of this algebraic fraction x plus 7, we multiply it by the denominator of this other algebraic fraction x plus 1. This will give us x plus 7 times x plus 1. So we take this times this equal to this times this. We put the equal to sign, take x plus 1 times 2x plus 8. Next thing, we have to expand the brackets. X times x gives us x squared plus x times 1 gives us x plus 7 times x gives us 7x plus 7 times 1 gives 7 is equal to x times 2x gives us 2x squared plus x times 8 gives us 8x plus 1 times 2x gives us 2x plus 1 times 8 gives us 8. This will give us x squared plus x plus 7x gives us 8x plus 7 is equal to 2x squared plus 8x plus 2x gives us 10x plus 8. Next step, we are going to transfer all the terms at the right hand side to the left hand side. This will give us x squared plus 8x plus 7 minus 2x squared minus 10x minus 8 is equal to 0. Next, we are going to bring the like terms together. X squared minus 2x squared plus 8x minus 10x plus 7 minus 8 is equal to 0. Next, we have to simplify. X squared minus 2x squared will give us negative x squared. 8x minus 10x gives us negative 2x. 7 minus 8 gives us negative 1. This is equal to 0. Now, at this level, the next thing we are going to do is we are going to multiply all through by negative 1. You can see the coefficient of x squared is negative. Take negative 1 times x squared minus 2x minus 1 is equal to negative 1 times 0. This will give us, there is negative here. Negative 1 times negative x squared gives us x squared. Negative 1 times negative 2x gives us positive 2x. Negative 1 times negative 1 gives us positive 1. And this will be equal to negative 1 times 0 gives us 0. Next step, we have to solve this quadratic equation. We are going to solve it by factorization method. We need two numbers such that their sum is equal to 2 and their product is equal to 1. you'll see that those two numbers will be 1 and 1. 1 plus 1 gives us 2. 1 times 1 gives us 1. This will give us x squared plus, I'll replace 2 here with 1 plus 1 times x plus 1 is equal to 0. This will give us x squared plus, I will expand this bracket, 1 times x gives us x plus 1 times x gives us x plus 1 is equal to 0. Next, we are going to take this pair, we factor out the common term. X is common. X times x gives us x squared plus x times 1 gives us x plus, here these two terms, 1 is common. We are going to factor out x plus, we are going to write x plus 1 in brackets equal to 0. Now we have two terms. X plus 1 is common. We factor out x plus 1 times x plus 1 here. This will equal to 0. This will give us, at this level, we are going to say either x plus 1 is equal to 0 or x plus 1 is equal to 0. Here we are going to obtain x equal to -1 or x equal to -1. And in this case, we are going to see the quadratic equation has repeated roots. You can see the solutions, they are the same, -1, -1, which is true. We move to question F. For question F, we have x raised to the power 4 minus 11 x squared plus 18 is equal to 0. Here you notice that the highest power of x is 4. So this is a polynomial of degree 4. Now for us to solve this problem, we are going to start by letting, we're going to say let x squared to be equal to e. X squared being equal to e, then if we square both sides, x squared, all this squared will be equal to e squared. This will give us x raised to the power 2 times 2, which is 4, is equal to e squared. We need to express x to the power 4 in terms of e. So it gives us e squared. Next, we are going to replace x to the power 4 with e squared and x squared with e in this our equation that we solve for e. Writing down the equation, we have x to the power 4 minus 11 x squared plus 18 is equal to 0. We know x to the power 4 is a squared minus 11. We know x squared is simply a plus 18 is equal to 0. Now at this level, we can solve this quadratic equation by factorization method. You can see it is a quadratic equation. The highest power of the variable a is equal to 2. We need two numbers such that their sum is equal to -11 and their product is equal to 18. We take -9 and -2. -9 plus 2 gives us -11. -9 times -2 gives us 18. In this our equation, we are going to replace -11 with -9 plus -2. You know, -9 plus -2 gives us -11. That's why we have a plus sign here. If we put a negative sign, it becomes 11, which is something else. We put times a plus 18 is equal to 0. This will give us a squared plus -9. We know positive, negative will stay. -9 minus 2 times a plus 18 is equal to 0. This will give us a squared plus, we are going to expand this bracket, -9 times a gives us -9a, -2 times a gives us -2a, plus 18 is equal to 0. This will give us a squared, positive, negative will stay, a squared minus 9a minus 2a plus 18 is equal to 0. For this first pair, a is common, we factor out a. A times a gives us a squared. We bring down minus. A times 9 gives us 9a. For this second pair, we are going to factor out negative 2. Factor out negative 2. We know negative 2 times a gives us negative 2a. Negative 2 times negative 9 gives us positive 18. You'll see, looking at these two terms, you'll see 9 minus a is common. We are going to factor 9 minus a times a minus 2 is equal to 0. Now, at this level, we are going to say either, if this product is equal to 0, either a minus 9 is equal to 0 or a minus 2 is equal to 0. If we find a here, a will simply be 9. Here, a will simply be 2. The negative number crosses an equal to sign, it becomes positive. Now, back to our question. We are not looking for a. We are to solve for x and not a. We know that a is equal to x raised to the power 2. Replacing a with x to the power 2. X to the power 2 is equal to a. We are going to replace it here. This will give us x squared is equal to 9 or x squared is equal to 2. Here, for us to get our x, we're going to take square root. X squared is equal to the square root of 9, or the square root of x squared is equal to the square root of 2. Now, we know that if we take the square root of x squared as such, the square root of x squared, if x squared is equal to a, we know this will give us the magnitude of x is equal to a. And we know the magnitude of x, then this will give us x to be equal to plus or minus e. If you take the square root of x squared, it will simply give the magnitude of x. The magnitude of x will be equal to 3. This will give us x to be equal to plus or minus 3, or x will be equal to plus or minus root 2. Remember, the number 2 is not a perfect square. At this level, it simply means x will be equal to negative 3, or, because we cannot be working with a positive and a negative number at the same time, or x is equal to 3, or x is equal to negative root 2, or x is equal to root 2. Then we conclude, therefore, x belongs to the set. This is our solution set. That means the set of all the solutions of that given problem. Negative 3, negative root 2, and 3. We underline the solution set. We move now to the last question. Question G. We have 400x raised to the power 4 minus 389x squared plus 81 is equal to 0. For us to solve this problem, we are going to apply the same steps as in question F. We are going to start by saying let x squared be equal to t. If x squared is equal to t, then if we square both sides, we are squaring both sides because we need to get x to the power 4 in terms of t. We equal to t squared. Then x to the power 2 times 2 gives us 4 will be equal to t squared. We are going to replace it here. This will give us 400 t squared minus 389 t plus 81 is equal to 0. Next, we are going to solve this problem by making use of the formula method. We are going to compare this quadratic equation with the general form of the quadratic equation, a t squared, because here the variable is t, plus bt plus c equal to 0. This will give us a to be equal to 400, b to be equal to negative 389, and c will be equal to 81. By making use of our formula method, we know t will be equal to negative b plus or minus the square root of b squared minus 4ac. We divide all this by 2a. This will give us negative. We know b is negative 389 plus or minus the square root of negative 389 all this squared minus 4 times e. We know e is 400 times c. We know c is equal to 81. So we divide all this by 2 times e, 2 times 400. This will simply be equal to, we know positive, negative gives us positive 389 plus or minus the square root of negative 389 squared will give us 151,321. Negative 4 times 400 times 81 gives us negative 129,600. We divide all this by 2 times 400, which is 800. This will give us 389 plus or minus the square root of, we take 151,321 minus 129,600. We are going to obtain 21,721. Divide this by 800. At this level, we know the number 21,721 is not a perfect square. We are going to leave it in set form as such with the square root sign. Here, at this level, it simply means that t will be equal to 389 plus the square root of 21,721 all over 800, or t will be equal to 389 minus the square root of 21,721 over 800. Remember, we are not looking for t. We know t is equal to x squared. We are going to replace t with x squared. This will give us x squared to be equal to 389 plus root 21,721 all over 800, or x squared will be equal to 389 minus root 21,721 all over 800. Next step, we are going to take square root at the left hand side and at the right hand side for these two equations. We take square root, this will give us x squared. We take the square root of x squared, it will be equal to the square root of 389 plus root 21,721 all over 800, or the square root of x squared will be equal to the square root of 389 minus root 21,721 all over 800. We know this will give us the magnitude of x. That means a plus or minus sign will appear here. This will give us x to be equal to plus or minus. We are going to break this fraction. Root of 389 plus the square root of 21,721 all over the square root of 800, or here x will be equal to the same thing, plus or minus sign will appear here, square root of 389 minus root 21,721 all over the square root of 800. So this will give us, if we take root 800, this will simply be equal to, we know expressing 800 as a product of two numbers such that one of them is a square number, we can express 800 as 400 times 2. So this will give us the root of 400 times 2. This will be equal to root 400 times root 2. We know the root of 400 is 20. So this will give us 20 root 2. We are going to replace it. This will give us x to be equal to, for the first one, plus or minus square root of 389 plus root 21,721 all over 20 root 2. So this will give us here x will be equal to, for the first solution, consider the positive case, the root of 389 plus root 21,721 all over 20 root 2, or x will be equal to, we consider the next case, which is negative the root of 389 plus root 21,721 all over 20 root 2. So this is for the first one. We take now 2 star for the second. The second we have x equal to plus or minus the root of 389 minus root 21,721 all over root 800. We know root 800 gives 20 root 2. And this will give us x to be equal to, we take the positive case, the root of 389 minus root 21,721 all over 20 root 2, or take now the negative case, negative the root of 389 minus root 21,721 all over 20 root 2. Now we are going to give the solution set. The solution set, x simply belongs to the set. We are going to copy 1, 2, 3, 4 solutions. We start from the smallest. This will give us a negative the root of 389 minus root 21,721 all over 20 root 2, comma, we take the next, which is this, negative the root of 389 plus root 21,721 all over 20 root 2, comma, we go now to the positive solutions. This one is the next. Take the root of 389 minus root 21,721 all over 20 root 2, comma, and the last solution we have this root of 389 plus root 21,721 all over 20 root 2. We enclose the solutions and we are done with the correction of the exercise for application. If in case you have any problems, make sure you leave your questions at the comment section. Please, you like the video, share and subscribe to this YouTube channel. Thank you very much for watching.